get into it, seep or escape into it, right? Yeah.
Yeah. Yes, sir.
Yes, sir.
There's no room for air in it. I have filled it till the mouth and placed my thumb on the mouth. Clear, yeah?
Yes, sir.
Yes, sir.
And then what we do? We invert it in the trot. We invert it in the trot, and we are very careful of no air seepage, right, yeah?
Yes, sir.
Yes, sir.
There is no room, there is no space for air. As a result, what is to be your first observation of this tilt over? When you careen it, you are taking ample care of no seepage, fine. Oh, they are being those being arrested. Now being asked, what will be your first observation when you have turned it upside down?
Sir, mercury will adjust.
What happened to the mercury in test tube? Tell me, yes, Krish, you are saying something.
Sir, mercury will adjust. The mercury will adjust from the test tube. It will come down. The height will get low.
Agreed. And you know the reason for the same, isn't it? Of course, it is to adjust till it stabilizes. Correct? Yeah.
So to
Yes,
establish.
sir.
To adjust,
Yes, sir.
stabilizes. So what will be an ordained, or you say a very organic observation of ours, being mercury falls in the test tube. Correct?
Yes, sir.
Yes, sir.
Mercury falls in the test tube. Fall doesn't mean that it will subside to the level what you have mercury in the trot. That is what I don't mean. What I mean is it will come down. From whatever it was, it will come down. And as it comes down, what is generated over here?
So where?
It comes down.
The
What gets
vacuum.
generated there? Yes, tell me, Krish.
So vacuum.
Vacuum, right? Very good, Velan. A vacuum will get generated out here. There will be no air presence seen here. Correct? Yeah.
Yes,
No
sir.
presence of air will be seen in this part of test tube. Therefore, this gets vacuumated. Can we say that?
Yes, sir.
And the moment we say this gets vacuumated, what we are of the opinion that pressure over here is P naught or zero. What will you say? What will be pressure there?
Zero.
Zero.
Of course, zero. And why will it be zero? Because there is no air seen in that portion. Correct? Yeah.
Yes,
Yes,
sir.
sir.
Okay, so pressure there being zero, and pressure at this point is P naught. At this point is P naught. So if I ask you, what about pressure at this point? What are you to answer against the point shown last?
It should be P naught.
Pressure at that point, because outside of the tube we are but known to pressure. As it is open to atmosphere, pressure can read no exception to P naught, right?
Yes, sir.
Yes,
Yes,
Pressure
sir.
can read no exception to P naught. Reason it being out of the tumbler, and not only that, it is open to atmosphere, to be more precise, correct?
Yes, sir.
Yes, sir.
So it is ordained to read P naught. This also is to read P naught. What can you say about this point? The third shown over here. Tell me, yeah.
So it should also read P naught because at the same height.
Reason, yeah. What is the reason? Justify your answer, Krish.
So all are at the same level.
Very good. They are all at same level. And as we are talking of a particular level, we cannot say pressure will be a differential. If pressure is differential, then it cannot maintain the level. Correct, yeah?
Yes, sir.
So what will be pressure over here? P naught here, P naught here. Also, it should read P naught. As they are leveled, please do write. As they are leveled, pressure is ought to read the same. Correct, yeah? Think of one level inside water
Understand.
to get more. Yeah, got your point, got your point, Adesh. Think of a level, Adesh. I'm getting you a better fluid to understand. I have taken water, right, Adesh?
Yes, sir.
And then ask you what will be pressure over here. What will you say it is dependent on? You will say it is dependent on height, correct?
Yes, sir.
And you can write an equation P is equal to P naught plus rho GH for that point. Agreed?
Yes, sir.
If I ask you to maintain level and then for pressure at these point, what will you read? Will it be same or exception from this?
So it'll be the same.
So what did we come to know? We have derived or deduced something from here. And what that being, Adesh? It being
So
that
at the same level, they'll all be same.
Yes, if we are at a particular level, then pressure should be even, right?
Yes, sir.
Yes, sir.
Pressure being even, pressure is egalitarian. Egalitarian, why? Because we are on level egalitarian, correct?
Yes,
On
sir.
level we are egalitarian, so pressure is also to reciprocate. It will read the same. Find here.
Yes,
Yes,
sir.
sir.
Yes, sir.
And if it is so, then I can very well go ahead with what we wrote over here. The pressure will be similar to this point and this point, and they being open, pressure being P naught. So this should also read nothing other than P naught. Fine.
Yes,
Yes.
sir.
Yes, sir.
Okay, with this as the backdrop, let me be an ask on, can I use my static pressure equation? Now I am introducing a word here, which is static, and I am letting pressure prefaced by it. Why? You will get to know about dynamic pressure also, but later. Static pressure means fluid is not in flow. Am I clear?
Yes, sir.
Yes, sir.
The ones that we are through, they are all for static pressure. Correct here?
Yes, sir.
Yes, sir.
Yes,
Okay.
sir.
Be it P is equal to P naught plus rho GH or P is equal to P naught plus rho omega square x square by 2. What are they to be read against? Against the heading static pressure. Clear dear?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay, good enough. So, do I qualify? This is a question to all of you. Do I qualify users of static pressure equation here in this case?
Yes, sir.
Yes, sir. Since fluid is not flowing.
Doing. Yeah.
Very good. Very good. As the fluid is not flowing, we do qualify. And going by what you have admitted, let me write pressure equation for this point. Here is 0, right?
Yes, sir.
So I don't know what will it be. I start with PA and I write PA is equal to 0 plus rho GH. Will you approve of it?
So, what is rho?
Rho is the density.
Mercury.
Density of mercury.
Yes, sir. Okay.
Because that's the liquid in it. Correct, yeah?
Yeah. Yes, sir.
Yes, sir.
Is density of mercury, that's the liquid in it. And what do we get? Pa as A being this point. Pa as 0, yes, 0 plus rho GH. Agreement class.
Yes, sir.
Yes, sir.
Yes, sir.
And we do know that Pa is nothing but P naught, right? Yeah. So this can be marked as P naught as well. Agreed?
Yes, sir.
So I,
Yeah. Yes, Anish.
sir, could you just explain how you have equated pressure at A equal to pressure at in the vacuum?
I have not equated pressure at A equal to pressure at vacuum. What I'm using is a formula P is equal to P naught plus rho GH.
Yes, sir. Yeah.
Formula you are acquainted to, very conversant to, correct? Yeah.
Yes, sir.
Now I ask you to concentrate on this segment, right? Yeah.
Yes, sir.
Here I have pressure at this point 0, right?
Yes, sir.
And you have admitted on the uses of this equation as it is a static case, right?
Yes, sir.
So let me use this equation. Making good of this equation, firstly what I am to write is pressure at this point, which is 0, correct?
Yes, sir.
And then I go down by height h. When I go down by height h, I'm known to this area being filled by mercury. Everywhere is mercury barring the top, correct?
Yes, sir.
So, what is density of mercury? Rho taken by me. G, gravity. H, the height to which it rises, correct?
Yes, sir.
So, exclusively if I'm going for this point in isolation, I don't know only pressure over here. I'm writing it as PA. Find here.
Okay. Yes, sir.
What is PA to us? 0 plus rho GH. Fine. Where rho is
Yes, sir.
density of liquid mercury. Correct, yeah?
Yes, sir.
Fine. And now I factor in what should be pressure read at this point, which you have admitted should be equal to outside same level points. Correct?
Oh, yes, sir.
And outside is P naught. So what do I replace PA by? P naught, right? Yeah.
Okay. Yes, sir. Understood.
Okay, and that is to get us H. That is to get us H. What is H from here? P naught by rho G, right class? And this
Yes,
H,
sir.
nobody is greenhorn to. This H, nobody is greenhorn to. As we know that mercury rises to 76 centimeter at sea level, correct? Yeah.
Yes,
Yes,
sir.
sir.
So this
Yes,
is
sir.
how we get height to which mercury will rise. Put the value of P naught, rho and G, you will get as 76 centimeter at sea level. Fine class.
Yes, sir.
So this
Yes,
is
sir.
something that we are known to. This is not actually my question positioning. My question is positioned on something else, which is what I'll ask SC Varma. Now let me ask you, if you are not careful enough and let air did seep, if you are not careful enough and let air did seep, so you being slightly non-challenged, air did find virtue in your non-challenge and didn't make a seep. If air makes a seep, then what can you say about it? Will be greater or less than 76 centimeter at sea level. Quickly, dear, come on. These questions are not to ask for this
It
long
should be lesser
powder.
than. It should be lesser
Of
than.
course, it should be less than H.
Yes,
Why
sir.
should
Yeah.
it be less
Yeah.
than H? Because bottom is fixed P naught, correct?
Yes,
Yes,
sir.
sir.
And here you will never be getting zero. You will be getting something other than zero, right?
Yes,
Yes,
sir.
sir.
Because it is no more vacuumated. There is air in it, correct? Yeah.
Yes, sir.
Yes,
Yes,
sir.
sir.
And if air is to need any pressure, then what we have to see? We have to see this getting you, this equation getting you some P over here, and that P will feature in the numerator, right?
Yes,
Yes,
sir.
Yes,
sir.
sir.
So it will be P naught minus P. Say me yes or no?
Yes, sir.
So one
And
small doubt.
in this case, H should be less. The new H should be less than this H, correct?
Yes,
Yes,
sir.
sir.
Okay, good enough. So we got an answer to this. Now another question which I need to ask you, Ring. Let me place this arrangement in an elevator. Find ya?
Yes, sir.
Okay,
Yes, sir.
yes, sir.
I say I'm placing this arrangement in an elevator. Okay, dear. An elevator is moving up with an acceleration A. Fine. Please write it down. If we place this arrangement in an elevator, if we place this arrangement in an elevator which is moving up with an acceleration A, which is moving up with an acceleration A, height to which mercury rises, height to which mercury rises is H prime. Height to which mercury rises is H prime. Option A. H prime will be less than 76 centimeter, equal to 76 centimeter, greater than 76 centimeter. Less, equal, greater, and mind you, the elevator is open. Find here, it is not confined. The elevator is open so that air can make an easy pass. Got it, dear?
Yes, sir.
Yes, sir.
Yes, sir.
What shall then be the case? Think about it. A level 1 objective SC Varma should not ask for this long thinking. Again, I say, tell me, dear, you are in an elevator, you have placed this barometer, as we call, everyone must be known to this, in the elevator. An elevator is moving up with some acceleration in. What is your
So,
height? Yes, dear.
so it will be less.
Okay. Okay, Vedant is going with it will be less. Krish, what about you?
Sir, I have two things in mind.
What are they?
The first thing, it should either be less or same, because the same, because we took pseudo force also into consideration last time.
Okay. So same or less, both you are on with. Is it so? And why same?
So because last time you told, so we did an experiment, no sir, like where we keep
Yeah.
a stock and the elevator is moving up.
Okay, their x remained the same. That is what I are referring to, is it?
Sir.
Okay, Adesh, what is your case?
Sir, I'd say H will be less than 76 centimeter.
Yeah, exactly. It should be less than it, Krish. Krish, please don't get in any way. If I am getting you this question is in isolation because there is no flotation case out there, right, Krish?
Yeah.
There is nothing floating in it, right, Krish?
Yes, sir.
If there were to be anything floating in this, of course, I would have gone with X will remain the same. Here you are to read vis-a-vis whatever we read that day, and that being G will be removed by G effective, right?
So 1 second, my mom is calling, sir. 1 second.
Sure. G will be replaced by G effective, right, Adesh, Vedant?
Yes, sir.
Yes, sir.
So if we replace G by G effective, then of course we are to get over here rho G into H effective, right? Because we
Yeah.
are
Yes, sir.
effective. And that should equate to the same P naught, correct? Yeah.
Yes,
Yes,
sir.
P naught doesn't change as it is open to atmosphere. P naught is undeterred. It is to read the same. Find yeah.
Yes, sir.
Yes,
sir.
sir.
And then from here, as the two of you did indicate, H effective must be less than this H. Why so? Because G effective is greater than this G, right?
Yes, sir.
Yes, sir.
This G effective, G plus A, correct? Yeah.
Yes, sir. Yes, sir.
Yes, sir.
Okay. So what do we get from here? H effective will be less than 76
Yes, sir.
centimeter. Am I clear?
Yes, sir.
Okay, good enough. So these were a few simple questions on barometer from SC Varma. Now let me grow my brain on them and ask you a few questions of my articulation. Question number 1. I puncture a hole here. Is it okay? What we
Yeah.
do, we puncture a hole here at this point. Visible?
Yes, sir.
Yes, sir.
Okay, that means level which is lower than mercury. Can we say that?
Okay.
Yes, sir.
Okay.
Yeah.
So if I am to punch a hole here, then what can you say about mercury? Mercury will spurt and spurt at an angle normal, which I'm showing over here. Find here.
Yes, sir.
Yes, sir.
Mercury will spurt and spurt in this direction, will spurt in this direction, or will not come out at all. There are 4 options. 3 directions shown, and the last being will not come out at all. What say, Krish? Are you back?
Yes, sir. Yes, sir.
Tell me, dear.
So mercury.
We have punched a hole there. We have punched a hole there. Find here.
Yes, sir.
Which is at a level lower than that of mercury in the test tube. Find here.
Yes, sir.
Then according to you, what should happen? Mercury should spurt following one of the 3 lines or shouldn't come out at all. Think about it.
Yes, sir.
Sir, it shouldn't come out at all.
Yes, dear. Yes, Adesh.
Sir, I'd say it shouldn't come out at all.
Why so?
Sir, because aren't the forces acting in vertical components?
So it will
Forces
come
are
out.
acting in the vertical direction. Also, forces are to act horizontally, right, dear?
Yes,
Of
sir. So it
course,
will
we
come out.
push mercury tube, correct? Sorry, test tube. Look, equate from all the sides.
Yes.
It is not that liquid is not applying force on the wall of test tube. Are you of the opinion that liquid will not apply force on the walls of test tube?
Yeah, now
Sir,
I'm
I
not.
think it will come out normal to the surface.
Okay, Krish, your take here.
So I don't think so. It'll come out.
Okay, let's try to figure it out. Any liquid, be it, any fluid, be it, it flows from which pressure zone to which pressure zone?
So
Higher
high
to
to
Sir,
lower.
higher to lower.
Good. From high to low. Now, pressure just outside the punctured area is P naught.
Yes,
Yes,
sir.
sir.
Yes, sir.
Pressure just outside the punctured area, how much it is? P
P
naught,
naught.
agreed?
Yes,
Yes,
sir.
sir.
And pressure just inside of that area, how much?
P-
Less than P naught. Why?
Yes.
Because it will be P naught here.
Yes, sir.
P
Yeah.
naught when you go down by height edge. If you are at height edge prime, see for yourself, what will it be? It will be less than P naught. Yes or no?
Yes,
Yes,
sir.
sir.
Yes, sir.
Because P naught will be rho GH. You are not going up to H. You are limiting yourself to H prime. So what will be pressure over here? Just within the walls at the point or level of puncture. What pressure you are to read? Less than P naught. Agreed?
Yes,
Yes,
sir.
Yes, sir.
So pressure inside is less, outside more. Why on earth mercury will come out? If it comes out, it is moving from higher pressure zone, sorry, lower pressure zone to higher pressure zone. Correct, yeah?
Yeah.
Yes,
So,
sir.
Are you getting it? Yes or no?
yes,
Yes,
sir.
Yes, sir.
So, what we are to say? I'll go with Krish. Mercury will not come out. Correct, yeah?
Yeah. So one
Yes,
small
sir.
question.
Yes, Krish, tell me.
So as pressure inside at that point is lesser, so won't air come inside?
Air can come provided you're allowing it a passage, right? You're talking of mercury. Mercury high on density, yeah.
Yes, sir. Yeah.
Very high on density. It is akin to the wall, as wall is wafer thin, you know. So it is more stronger, I am to say, than the wall of test tube. Correct? Yeah.
Yes, sir.
Okay, so it will not allow passage of air. Therefore, what we are to see, air will not seep in, and accordingly, mercury also is not to come out. Let me now make a puncture here. I am puncturing here. Going by what Krish was asking for. Krish was asking for air to seep. Correct here? Correct, Krish?
Yes, sir.
You wanted air to enter the test tube. So let me be an allow. But for that, I'll have to puncture some other point, right?
Yes, sir.
Yes,
So
sir.
I have punctured it there. I have punctured the wall of test tube now at this point. Air can gush in. So air gushes in. And why will? You know that very well. High, this pressure is higher than pressure inside, so air will gush in. And as it is into rush, tell me what is to happen to the level of mercury.
So height will
First, are you endorsing the idea of air is now to seep, to gush into the test tube? Yes or no?
yes, sir.
Okay, so if air enters the test tube, then what according to you will happen to level of mercury in the test tube?
Sir, it will
So it
decrease.
will lessen or decrease, yeah.
Decrease, okay? And decrease too if you can reveal more. If you may reveal more,
Sir, it won't
decrease,
increase.
fine, I accept
Sir,
it. Yeah, if you can go beyond, yeah, tell me.
so to the level of the mercury in the trough.
Very good. It will decrease and decrease to the level of mercury in the trough. Why so? Because pressure everywhere must be P naught. The moment you
Yeah.
puncture and let air in, the moment you puncture and let air in, what will pressure read here, dear? Is P naught. Agreed?
Yeah.
Yes, sir.
And if pressure will read P naught, then it is bound to fall. It will have to fall and get to the level of outside points. Correct?
Oh, yes, sir.
Yes, sir.
So it will be even with the other points which are reading same pressure P naught, correct?
Yes,
Yes,
sir.
sir.
Got it, dear? Got this question, all of you?
Yes, sir.
Yes, sir.
Good enough. Right. Next. Given a piece of heavy wood, given a piece of heavy wood with very high density coin on it, given a piece of heavy wood with very high density coin on it, what will happen to H and X? What will happen to H and X if the coin flips in, if the coin falls in the tumbler? So there is a coin kept class. This is the coin, very high density. Is it okay? So
Yes,
much so that you can discount on density of wood. Clear, dear?
Yes, sir.
Yes,
So
sir.
very high density coin kept over here, and you let it fall off the wood piece. Clear, dear?
Yes, sir.
Yes,
yes,
sir.
sir.
It falls off the precipice, and it falls off the precipice into the tumbler. Fine.
Yes, sir.
Yes, sir.
Okay, so high is the density of coin that you can forego its volume, right? Yeah.
Yes, sir.
Yes, sir.
So it falls off the precipice, gets into the liquid. What, according to you, should happen to H and X? H will rise, X will rise, X will fall, H will fall, X will rise, H will fall, X will fall, H will rise. ITJ question. Tell me, dear.
So H will rise and X will fall.
Okay.
H will
Yes, sir.
Yes, sir. Same.
H will
Same.
rise, yeah.
X will fall. All of you, I presume, are in agreement with this thought process, correct?
Yes,
Yes,
sir.
sir.
So I take your point. X certainly should decrease.
Yeah, yes.
Now,
Yes, sir.
if X decreases, then this wood piece will move up.
Yes, sir.
Yes, sir.
Yeah, yes,
So
sir.
now wood piece is over here. Correct, dear?
Yes.
Yes,
Yes.
sir.
Now, what about this portion? Is void.
Yes, sir.
And if
Yes,
this
sir.
portion is void, what will water do? Will it let the way that it is, or will gush in?
Water will gush in.
Okay, so water fills this area. If water fills this area, what is to happen to HDR?
It will decrease.
It will
So
decrease.
what do with both X as well as H will decrease, correct?
So one
Yes.
small doubt. So is this
Yeah.
possible? Can we idealize this case in can we perform the same experiment and see?
In C.
Is it to work in real life, the same experiment?
Yeah, it will work. Why not? It is to work, definitely without fail. If you get very dense coin, and you are talking of the coin being so much so on density that when coin is let fall in the tumbler, the rise is not to be associated with the level of water owing to falling of coin in it. Are you okay with it?
Yes, sir.
So if you get that density, because see, what in actual will happen, you will have to associate some volume with it, correct?
Yes, sir.
Yes,
And
sir.
if that volume falls in tumbler, then water will rise in accordance, correct?
Yes,
Yes,
sir.
sir.
Yes, sir.
So water will rise in it. But at the same time, which is to ask for a higher volume of water? Will the
Wood.
displacement by coin or moving up by wood, correct?
Oh,
Yeah.
yes, sir.
Certainly moving up by wood will ask for more, as more void or voluminous void is generated over here, correct?
Yes, sir.
Yeah.
Yes,
There
sir.
is much fermentation will be. Definitely there is only this to be seen. Other than this you will not see. Other than this you will see only for one case, when the coin is also in flotation mode.
Yes,
Till
sir.
the time you are saying that coin sinks, you are to read the same. Yes, your reading can be a variation if and only if coin starts floating in water. Are you getting it?
Yes, sir.
Yes,
Yes,
sir.
Because
sir.
then you have taken comparable density of coin. Got it, Krish?
Yes, sir. Yes.
Okay. Next, question number
Beautiful
2.
question.
Yeah. Very simple question with feature. Another simple question I'm taking again from IIT. Write down. There are two liquids of density rho 1 and rho 2. There are two liquids of density rho 1 and rho 2. With a rod kept in vertical orientation as shown in the figure. With a rod kept in vertical orientation as shown in the figure. Rho 1, rho 2. If A is the area of cross section, if A is the area of cross section, and H1, H2 the respective height or length submerged, and H1, H2 the respective length submerged. You can see for yourself, H2 is the length submerged in rho 2 and H1 is the length submerged in rho 1. Correct, yeah?
Yes, sir.
Yes, sir.
Yes, sir.
Find buoyant force on the rod. Find buoyant force on the rod due to liquid rho 2. Find buoyant force on the rod owing to liquid rho 2. Tell me, dear. Owing to liquid rho 2, what buoyant force the rod is to experience? What will be the quantum of it? Area of cross section known to you, height H2 known to you. What buoyant force you are to say in experience? One. Now, if we come from the conventional understanding, which we do have, about weight of liquid displaced, correct, yeah?
Yes, sir.
Yes,
So,
sir.
if we go by that understanding, we are to write rho 2, area of cross section H2 into G. Say me yes or no?
Yes, sir.
Yes, sir.
Right, answer to this is 0. Now, why answer to this is 0? Why should it be 0 and how is it 0? It is 0 owing to the fact that they did ask you what rho 2 will apply. Rho 2 can apply force only in the direction perpendicular to the area which it is in contact, correct?
Yes, sir.
Oh, yes, sir.
The area vector, then you will say in alignment, whichever way you study. I say perpendicular because I take area to be area of surface, tangent to surface. Is it okay, dear? Don't get confused
sir.
over here if area vector is told. Area vector will be in alignment or opposite to it. Correct, yeah?
Yes, sir.
Yes, sir.
So perpendicular to the surface, if that is the only direction in which force can be applied by liquid or can be applied on liquid, right, yeah?
Yes, sir.
Either you say by liquid or on liquid, it can only be in the direction perpendicular, and we have rested our case on that, correct?
Yes, sir.
Okay. So if I apply force this way, then what is the effective force which I am applying on the rod? Zero. Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
So there is no way out. There is no possibility for rho2 to act in any direction other than A, horizontal, and B, as it is acting in the direction horizontal, there is no net force in vertical direction. Therefore, there is no scope of buoyant force to be applied by rho2. Agreed?
Agreed,
Yes,
sir.
sir.
And then I stretch it further. Pushing the envelope, I ask you a question. Will there be effect of rho2 presence seen or not? Will there be effect of rho2 presence seen or not in the calculation of buoyant force? Please try to read me correctly. The first one being I asked, will it be possible for rho2 to apply force, buoyant force? You said no, it is out of its capacity, it cannot. So we have ruled out the possibility of rho2 applying any buoyant force on rod. Then I asked, going further, I asked, is it possible for rho2 to show in force of buoyancy equation? Will rho2 show in force of buoyancy equation? Yes or no? Will there be buoyant force on this rod or not? Fine, not due to rho2. Will it be there due to rho1? Yes or no?
Yes,
Yeah,
sir.
sir.
Yes,
And
sir.
it will be there due to rho1. Will in that equation rho2 show? Will it partake? Yes or no?
Sir, can you repeat the question?
Will in the equation for buoyant force which the rod is subjected to, rho2 show or not? Will it be featuring? Will it be partaking?
Yes, sure,
Okay,
sir.
tell me what is according to you buoyant force due to rho1?
Sir,
What is according to you buoyant force due to rho1? Then what will you say? You will say it will be equal to weight of rho1 displaced. Correct? Yeah.
Yeah,
yes,
yes, sir.
sir.
Yes, sir. Yeah.
Okay, I'll ask you, can you show it to me mechanically using Newton's second law of motion? Mechanically, can you show? You will say, of course. Let us take pressure equation here, which is P naught. So P naught into A downwards, right here?
Yes,
Right.
sir.
Yes, sir.
Yes,
And
sir.
what is pressure equation here? Any one of you, quickly, please. At this point, what is pressure equation? Come on, tell me, yeah.
Fresh.
So
What
rho
is
one,
pressure equation?
so rho1 A H2 plus H1 into G.
H1. Yeah.
Okay, so here the pressure will be rho 2, P naught of course will be there. So P naught plus, right?
Yes, sir.
P naught
Yes,
plus
sir.
rho 2 H2G plus rho 1
H1.
H1 G.
G.
Agree?
Yeah, yes, sir.
Yeah,
Yes,
yes.
sir.
Agree, all of you?
Yeah, it
Yes,
is.
sir.
Yes, sir.
Okay. And this one multiplied with area will get me force. Find here.
Yes, sir.
Yes, sir.
Yes, sir.
And we are known to that buoyant force or force of buoyancy is nothing but after effect of variation in pressure, correct?
Yes, sir.
Yes, sir.
Yes,
So
sir.
let us Find the differential on pressure. What do we get to see? P naught A gone, correct?
Yeah, yes, sir.
Yes, sir.
What do we get the additional pressure or force as? Is rho 2 H2 plus rho 1 H1 whole into GA, right there?
Yes, sir.
Yes, sir.
So please be very careful on the language of question. Clear, dear?
Yes, sir.
This
Yeah.
Yes,
is
sir.
not being applied. This has got absolutely no link, no trucks with rho 2, because rho 2, if it is asked in isolation, you are to negate it being an any way related to buoyant force, correct?
Yes, sir.
Yes, sir.
But when is asked that, okay, rho 2 in isolation cannot produce force of buoyancy, but in the equation for force of buoyancy, will it partake?
Yes,
Then
sir.
what you have to say?
Yes, sir.
Yes,
Yes,
sir.
sir. Well,
The partake, and you can show the partake very well from here, right, class?
Right,
Yes,
sir.
yes, sir.
Okay, so this is a very important part which I wanted to highlight. It has already featured in IIT. Okay, dear?
Yes, sir.
Yes, sir.
Okay, let's further now. Write down. A block of mass mkg, a block of mass mkg is placed in an empty vessel as shown in the figure. Is placed in an empty vessel as shown in the figure. Water is poured in this vessel. Water is poured in this vessel till the time block gets completely submerged and beyond. Till the time block gets completely submerged and beyond. Normal applied by the wall or the bottom, make it normal applied by the bottom of vessel, normal applied by the bottom of vessel will, option A, increase continuously, option B, increase then decrease, option C, decrease and remain constant, option D, none of the above.
So can you repeat option C?
Decrease and remain constant.
Okay, yes, sir.
Now there are two cases under which you can study this. I am asking for both the case. First case being, both the cases, first case being that there is enough undulation for water to seep. Is it okay? There are
Yes.
two cases for which you can study this experimentation, correct, yeah?
Yes,
Yes,
sir.
sir.
Yes, sir.
And the two cases being, first case, first of the two, there are undulations, so water can seep. Clear, dear?
Yes, sir.
Yes, sir.
Case to seep means seep between the two surfaces, surface of object and bottom of vessel. Is it okay? Surface
Yes.
of object and bottom of vessel, there is enough gap for water to seep. Clear, dear?
Yes,
Yes,
sir.
sir.
Second case, there is no gap. There is absolutely no room for water to seep. They are in contact, firm contact. Find here.
Yes, sir.
For both the cases you are to read. Tell me what will happen to normal provided by bottom. Let's take them in turns. The one shown over here, take this first. Tell me.
So will
Right
it be so for the first one where there is gap, will it be decrease and then remain constant?
Yes, of course, that will be the case here. Why will it decrease? Let us talk of this area. Let us talk of this area first. If it is filled up to this level, this area is experiencing P0 pressure, right here?
Yes,
Yes,
sir.
sir.
And pressure over here certainly will be more than P0.
Yes, sir.
Yes, sir.
So pressure from bottom multiplied with area, which we are assuming to be same because we are talking about macro area, correct here?
Yes, sir.
Yes,
So
sir.
that will remain the same. Therefore, what will you say? As you are increasing level of water till the time it gets completely submerged, pressure at top is P0, thereby force on the top surfaces P0 into A. Mind you, what did I say? It is under a rider. What that means? Till the time it is completely submerged. Correct, yeah?
Yes, sir.
Yes, sir.
So pressure here being P0 and it remains P0. What force you are to get that pressure translated to will be P0 into cross-sectional area, which is A, correct?
Yes, sir.
Yes, sir.
Whereas pressure over here, what is happening to pressure as the level is rising? As the level is rising, what is happening to pressure? Level rising under a cap. What that cap? That it should not get submerged. The object should not get submerged completely, correct?
Yes,
Or
sir.
up to
Yes,
getting
sir.
submerged. Or you can also rephrase it to up to getting completely submerged. Find here.
Yes, sir.
Yes, sir.
So till that time, what is happening? Pressure here will keep on increasing, correct?
Yes,
Yeah,
sir.
yes, sir.
Yes, sir.
So pressure top remains the same, bottom is increasing. Can we say that?
Yes, sir.
Yes, sir.
Yes, sir.
Therefore, what is happening to normal? Normal is decreasing, same yes or no?
Yes, sir.
Yes,
Yes,
sir.
Normal is
sir.
decreasing. Why? Because there is force, and force in which direction? Net force. Net force due to liquid in which direction? Upwards. Yes?
Direction.
Yes, sir.
Yes, sir.
Now you will ask me that why did I contain myself to there will be a rise in pressure only up to somewhere. Even if you go beyond, there will be rise in pressure. Pressure will rise over here, right here.
Yes, sir.
Yes,
So
sir.
beyond this level, this is the level which I wanted you to keep to. But if you go beyond this level, if you go to this level, then pressure will rise again because it will be more than this height will be more. This height is, let's say, H1 will be more than this height, correct?
Yes, sir.
Yes, sir.
So pressure will increase. Of course, pressure will increase, but the same increment will be seen by the top as well.
Yeah. Yes, sir.
Yes, sir.
Pressure will increase at bottom, no doubt about it. But top, which was contained initially, right here,
Yes, sir.
Yes, sir.
Yes, sir.
which was contained initially open to this being exposed to air, thereby P0 was maintained. Now that will also find a rise in pressure, correct here?
Yes,
Yes,
sir.
sir.
Yes, sir.
So what will be the effective rise in pressure? 0. Why? Why?
Yes, sir.
Why effective rise 0? Tell me dear.
So
Why
because
did I say effective 0? Whatever the bottom will increase by, will increase the top by, correct?
yes, sir.
Yes.
Yes, sir.
I'm not getting a yes from Adesh and Vedant.
Yes,
Whatever
sir.
Yes,
the
sir.
bottom will increase by will increase the top. Why I'm saying so? Why I'm saying so?
Depth increases.
What will be pressure increment here? Tell me. That's the reason you are quiet. These do ask here. I told you will not be getting these. So why did it increase? This was the level, right?
Yes, sir.
Yes, sir.
Now you go beyond it. By what distance you are increasing it? Let us say delta H.
Yes,
Yes,
sir.
sir.
Okay, what is the level now? This is the level. Find here.
Yes, sir.
Because of delta H, what will be increment in pressure over here? Rho G delta H, agreed?
Yeah, yes,
Yes,
sir.
sir.
Because it was H, whatever it was, now we have increased it by delta H. So this point will be the pressure increment at this point, correct? This point.
Correct.
Yes,
Yes,
sir.
sir.
And same will be increment over here as well, right?
Yes, sir.
Yes, sir.
So this will also increase by the same amount, rho G delta H,
Yeah.
agreed?
Yes, sir.
Yes, sir. Yes, sir.
What is the effect of increase in or rise in height of liquid? What is the effect of rise in height of liquid? Come on, tell me. Will there be any effect?
No, sir.
No, sir.
No.
After it's submerged, no.
When from you are
So,
discounting on effect? Till
so
what
after it
was
is
effect could
submerged,
be seen, and when from you did discount? Tell me, dear.
so after the block of mass m is completely submerged.
Yes. Till the time it was 2 summers, this was maintained at P naught and this was rising. Correct?
Yes. Yes,
Yes,
sir.
Now,
sir.
completely submerged, and when we go beyond it, then whatever is increment at bottom will be increment at top.
Yes, sir. Yeah.
Yes,
So
sir.
top is pushing down, bottom is pushing up. Thereby, net effect of the change or rise in the height of liquid is zero vis-a-vis pressure. Correct?
Yes, sir.
Yes, sir.
So what we'll say, we'll go by what Krish did here. That is, initially it will decrease and then it is to remain the same. Mind you, through and through, I have not taken block leaving surface of vessel. Correct, dear? It may
Yes,
also
sir.
be
Yes.
possible to start floating. Correct?
Yes,
Yeah.
sir.
Rule that possibility out. Am I clear?
Yes, sir.
Yes,
Yes.
sir.
Okay, fine. Now, next is this. Tell me in this case what happened when water was not allowed a seepage. When water was not allowed a seepage, in this case, quickly, dear, come on.
Yes, sir.
No room for water yet between the two layers, bottom of object and of vessel. There is no room. Earlier, what will you say about normal applied on the block in this case?
So one
It is
second.
not FPT. Come on, tell me something about it. You are pouring water. You are pouring water slowly into it. What is to happen to normal applied on object by vessel's bottom?
Uh,
Yes, Adesh, take a call.
so 1 minute.
So should it increase continuously?
Okay. And why so, Krish?
So because there is no force, there's no pressure in between the gap. So there's only water is only continuously added. So normal should increase on the surface.
Normal on the block.
Okay,
I am
on
not related to what is normal. I am never related to normal on the surface. I am talking normal on the block. Getting it here?
yes, okay, normal on the block. Okay, sir.
That is what we have kept to. Like here, the previous case also the normal was on the block only, correct?
Sir, because we wrote normal applied by the bottom of vessel. That's why.
Huh? At the bottom of vessel, where? On the block.
On the block. Yeah.
Right here.
Oh boy.
Tell dear. Anyone? Come on, quickly, dear. There are a few more questions to be taken. Liquid is more on questions to gain on concept. Tell me, dear. Tell me FBD for draw FBD for the block. FBD for the block, one will be normal, which is what I'm talking about. Correct, dear?
Yes,
Yes.
sir. mg.
The other will be P naught into A, which you can mark from top atmospheric pressure, or later it is to change. Fine, we know that. Then what else? Then you will say mg, right? Mg will act in which
Yes.
direction? Downward direction. Fine, yeah.
Yes, sir.
Yes, sir.
Okay. So on the block, these are the forces acting, and these are to remain the same, irrespective of to what height water rises till the time. Now see for yourself. Water being here, whatever height it is at, normal, the same. Why? Mg, P naught A, they are not disturbed, correct?
Yes, sir.
Yes, sir.
Because water can only apply force in which direction? Normal to the surface, and it has not been allowed a seepage, correct? So there will be no
Yes.
force in upward direction. Find yeah.
Yes, sir.
Okay, now it is getting completely submerged and goes beyond it. What happened at the top? What happened to pressure equation at the top? Will it increase? Krish?
Yes,
Yes,
sir.
sir. Yes, sir.
And
Depth increases.
bottom, of course, has got no umbilical cord relation with pressure, correct? Yeah, and there is no water. Find yeah.
Yes, sir.
So this pressure increment at the top, what will it do to normal?
They'll increase.
The increase.
So what will you say? Up to the time it is getting completely submerged, normal is not to change, correct?
Yes, sir.
Yes,
Yes,
sir.
sir.
If you go beyond, normal will increase, correct? Yeah.
Yes, sir.
Yes, sir.
Okay, so that is what we learned from here. Now a question very susceptible to feature in IIT JEE. Write down. Very
Sir, so the
susceptible.
option is not. So the option
Yes,
is none
yeah.
of the above, no, sir. So the option is none of the above.
Come again, dear. What were the options?
Sir, increases continuously, increases then decreases, decreases and then remains constant, and none of the above.
None of the above. It should be constant and then increases, correct?
Yes, sir. Yeah.
Yes, sir.
Please write that down as well. Constant and then increases. None of the above will not be able to relate later. Fine?
Yes,
Yes.
sir.
Constant and then increases. Okay, next. Otherwise, indicative of this being a tentative question for IIT, please write down. There is a spherical high density. There's a spherical high density ball kept at. There's a spherical high density ball kept at the bottom of vessel, the bottom of vessel containing liquid of density rho, as shown in the figure. Containing liquid of density rho as shown in the figure. Find force due to liquid. Find force due to liquid on the upper surface ABC. On the upper surface ABC of sphere. On the upper surface ABC of Is it okay, dear?
Yeah.
Yes,
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 sir.
sir.
So upper surface ABC of the sphere, you want to get know on what force is applied by liquid on this surface. Find here.
Yes, sir.
Yes,
Yes.
sir.
If we go by the conventional method, if we go by the method P is equal to P naught plus rho GH, which is what is known to us, correct?
Yes, sir.
Then at every point on the hemisphere, which is over here in reference, correct? Yeah.
Yes, sir.
Every
Yes, sir.
point on the hemisphere in reference, pressure will change.
Yeah.
Yes, sir.
Why? Because they are at different depths. Correct? Yeah. Say me yes or no.
Yes, sir.
So pressure keeps on changing. As pressure is changing, what shall I do? I'll have to take an element and then go for integration. By that, what I mean, I'm showing you a magnified figure over here. First, I will say, okay, let us take pressure at this level, correct?
Yeah. Yes, sir.
This level will be at what point? Please do check here because this is the conventional method and this also should be known to you. This is not to fail you ever. This is foolproof. Are you getting it? Shortcuts we
Yes.
get from conventional methods only. Find here.
Yes,
Yes, sir.
sir.
Okay. So this is the level of water. Find here.
Yes, sir.
Yeah. Yes, sir.
And I have taken one level, a particular level. Fine. A particular at a particular depth. What depth it is? Y. Fine.
Yes, sir.
Yes.
What will be the equation of?
Sir, I cannot see your camera.
Yeah. We cannot see.
Are you there?
Yes, sir.
Yes, sir. Now.
Ah, fine. Now this is at a distance y, correct? Yeah.
Yes, sir.
Yes, sir.
Now what depth y? So what will be pressure at this point? Pressure at this level rather will be P naught plus rho g y. Agreement, all of you?
Yes,
Yes,
sir.
Yes,
sir.
sir.
Okay, good enough. So P naught plus rho g y. Fine. What I am to ask you is this pressure to translate to force? You will say, of course. Pressure multiplied with area will get us force. Then I'll ask
Yes.
you which area. Then I'll ask you pressure multiplied with which area gets you force. So you will recollect the first class on pressure when I told you that force means force should act perpendicular to the area taken, correct?
Yes,
Yeah.
sir.
Yes, sir.
Got it, dear?
Yes,
Is
sir.
there with you?
Yes, sir.
So this pressure will certainly translate to force, no doubt about it. But force will be shown acting perpendicular to the area taken by us. Agreed?
Yes,
Yes,
sir.
sir.
Then we will have to relate area to this level first. Correct? Yeah.
Yes, sir.
Yes, sir.
And area, I'm showing you the area now. Okay, this is the area.
Yes, sir.
So area, as you know, area should be, if I draw a perpendicular, then it should go up to the center. Okay?
Yes, sir.
This to me will be the area vector. Check it out, the area vector. Are you getting it?
Sir, I don't understand the area vector part.
Area. This is the sphere. This is the sphere. Listen. Look, Krish. This is the sphere that I'm speaking of, correct?
Yes, sir.
Now, if I talk of a ring, basically I'm talking of a level, so I'm talking of a ring, correct?
Yes, sir.
So there is a ring. At a particular level, you will get a ring. Correct, yeah? Yes or no?
Yes, yes, sir.
Yes, sir.
Now to that ring, you ought to associate area. Correct?
Yeah, yes, sir.
So will it be this area or not? This area, small area here. Getting it?
Yeah,
Yes.
yes, sir. Yes,
This
sir.
area.
Yes, sir.
Getting it, Krish, or not? No, I'm not getting a confident yes from you. This is the ring that I'm talking of, Krish, and ring is of some thickness. Getting it?
Yeah,
Ring
yes,
is
sir.
of some thickness. Getting it? Are you able to see
Yes,
that
sir.
dark mark, gold mark?
Yeah, yes, sir.
This is the thickness, correct?
Yeah.
I'll have to associate this thickness with ring. Why so? Because I want to associate area with it. Why so? I'm to calculate force on it. Correct, dear?
Yes, sir.
So this area vector will be in which direction? Area vector. Will it not be perpendicular to this line?
Yeah, yeah, yes, sir.
Okay. So area vector is being shown this way. Agreed?
Yes,
Okay,
sir.
yes, yeah.
Getting it?
Yeah.
Area vector is being shown. Is it okay? Area vector, not area. Area
Yeah,
vector. Is it okay?
yeah, yes, sir.
Okay.
Yes, sir.
This area vector, as I am to take force normal to it, correct?
Yes, sir.
Yes,
So
sir.
it should be in the direction of area vector, agreed or not?
Yes, sir. Yes, sir.
Yes, sir.
Agreed all of you, yes or no?
Yes,
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 sir.
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 So this pressure, when multiplied with area which I have shown you just now, right here.
Yes,
Yes,
sir.
sir.
Now let me write that area for you. If this angle is theta, then what will be radius of this elementary ring that I have taken? R cos theta, agreed?
Yes, sir.
R cos theta, agreed or not?
Yes,
Yes,
sir.
sir.
And 2 pi r cos theta will get me perimeter.
Yes,
Yeah,
sir.
yes, sir.
Yeah, yes, sir.
And 2 pi r cos theta multiplied with r d theta will get me area. How did I get r d theta? This will subtend what angle at the center? D theta, this length, correct? Yeah.
Yes,
Yes,
sir.
sir.
Yes, sir.
So what will be the arc length? R d theta, correct? Yeah.
Yes,
Yes,
Yes.
sir.
So arc length R d theta multiplied with the other length perimeter will get you the area, right?
Yes,
Yeah.
sir.
yes, sir. Yeah.
So this is the area. Area of what? Area of ring. Krish, is it clear? This
Yes,
is a
sir.
repeat trick, by the way. You have seen this in electrostatics, correct? Yeah.
Yes, sir. I forgot. I got confused with the area vector. Now I understand, sir.
Okay, fine. So this is what to you? This is to you the area of ring, correct?
Yeah, yes, sir.
Yes, sir.
We are to find force acting on it. So we very well know force is to be shown in which direction. I'll take another chalk piece color. Force is to be shown in which direction? Force is to be shown in this direction. Can you show it this way? Force, because force will always be perpendicular, right here.
Yes, sir.
Yes,
sir.
sir.
So this is the direction of force.
Yeah.
And what is force? Force to be equated to? Force is to be equated to pressure multiplied with area, right here.
Yes,
Yes,
sir.
sir.
So P naught plus rho gy. P naught plus rho gy is the pressure there, agreed?
Yes, sir.
Yes,
Yes,
sir.
sir.
And multiply with the area, which is this to us, correct?
Yes,
Yes,
sir.
sir.
Okay. What is this to get you? This is to get you force, correct?
Yes,
Yes,
sir.
sir.
Yes, sir.
No?
Yes, sir.
sir.
Yes, sir.
Yes,
And
sir.
force will be seen everywhere on the ring, right here. Every portion of ring, there will be force in the direction, this way. Everywhere, this way, this way, this way, this way, this way. Some yes or no?
Yes, sir.
Yeah,
Yes, sir.
yes, sir.
Okay, perpendicular to the area or in alignment with area vector, correct? This
Yes,
way,
Yes,
this way.
sir.
Okay?
Yes, sir.
Now, that's the case, then horizontal force will get cancelled. Horizontal component of force will get cancelled. See for yourself, right here, force this way. So horizontal will get cancelled from all the sides.
Yes,
Yes,
sir.
sir.
Yes, sir.
Yeah. Yes, sir. There will be vertical down.
Vertical, right here. Clear to all of
Yes,
you or
sir.
not?
Yeah, yeah.
Horizontal from all the sides because there's a counterpoint for every point you take. Horizontal will get cancelled. We'll be left with only vertical component. Agreed?
Yes, sir.
Yes, sir.
Now tell me, if this is theta, this will also be theta.
Yes, sir.
Yes,
Right?
sir.
Same.
Yes, sir.
Opposite. So theta, theta. So what will you get over here? Force equal to F sine of the angle theta. Agreed?
So,
Agreed or not?
Yes, sir.
Yes, sir.
This is F. This should be multiplied with sine of the angle theta. Correct?
Yes, sir.
And then we shall go for integration. Correct? Yeah.
Yes, sir.
Integration from where to where? Integration from theta equal to 0 to theta equal to pi by 2. Check it out.
yes, sir.
When you take pi by 2, you take all the rings into consideration. Correct?
Yeah, yes, sir.
Yes, sir.
Okay. So this is the conventional method, and this is to get you an answer. There's a term we generally use, gauge pressure. When we say gauge pressure, we have to discount on P naught, because gauge pressure is the additional pressure beyond P naught. Is it okay?
Yes.
Yes,
Yes,
sir.
sir.
They can ask for gauge pressure, that will be easier for us to calculate, because this P naught is like a hindrance. Yes, you will have to find a relation between y and theta, because there are two variables over here. You can see for yourself. Correct? Yeah.
Yes, sir.
Yes,
This
sir.
theta and the other is y. So there are two variables. You will have to relate y with theta. Clear? Am I clear?
Yes, sir.
Yes, sir.
Yes, sir.
The methodology is there with you. Please check the methodology, what I have done, and be convinced on it. Check it out. Anything to ask, please feel free ask. How can you get rid of y? By taking, same as I've asked you, gauge pressure. You can get rid of y. That means you will assume the level to be here. And then you can easily relate y with r cos theta. How? If you take no level, no gauge, no pressure, but gauge pressure if you are taking, then you are assuming that this is the level. Clear here?
Yes, sir.
And then
Yes,
Yes,
sir.
height
sir.
y, if you take y, this is y, then you can relate y with theta easily. How? This angle was taken, this was y, this is y now, effective y. So what will y be in terms of cos theta? What you can write y to be? Y will be r minus r sin theta, correct? Because I've taken this as theta, correct?
Yes,
Yeah,
sir.
yeah. Yes, sir.
This r sin theta, agreed?
Oh, yes, sir.
So what will be y to us? R minus r sin theta, yeah?
Yes, sir.
Yes, sir.
And then you will be speaking for gauge pressure, because gauge pressure means you have negated the effect of atmospheric pressure. So how can you negate the effect of atmospheric pressure? When you take it at this level itself.
So
Okay, you have to
after,
produce this level. And then you can
so
go
after,
for integration. So that being one of the process, and you see for yourself what you have to do for that. You have to go for integration, actual integration you have to apply, right, Krish?
sir.
Is it clear or not? Check first here.
So one small question. So after we calculate for gauge pressure, how do
See,
we factor in atmospheric
I'll
pressure?
make it clear to you. I'll make it clear to you. By other principle. See, Krish. I don't know why over here, correct?
Yes, sir.
So why is the bone of contention, correct?
Yes, sir.
Let us say in question is given to you that this is capital H, correct?
Yes, sir.
How will you now change y to capital H and R theta? This is capital H.
Yes, sir.
So up to this point, there is no problem. Capital H done.
Yes, sir.
Check here.
Yeah.
Capital H up to this point, no problem. Capital H done. Yes or no?
So yes, sir.
Yes, sir.
Okay. What I am left with is
Y.
y minus h.
Yes, sir.
And what is y minus h? R minus r sin theta for us. Correct?
Yes, sir.
Correct, Krish?
Yes, sir.
Yes, sir.
So y is written in form of h plus r 1 minus sin theta, that is in y is presented as function of theta. Agreed?
Yes, sir. Yeah.
Yes.
So we can replace it and we can write as function of theta. If h is given, good. If h is not
Okay.
given, we are left with no option but to discount. Correct here?
Yes,
sir.
sir.
Sure.
Okay, so if H is given, I'll place it. My contention was to write Y in terms of theta. I think that is fine with you now.
Yeah, yes, sir.
Yes,
So
sir.
that can be easily done and we can integrate it. Okay. Yeah, gauge pressure, Krish, that you asked me. Gauge pressure is pressure minus atmospheric pressure.
No, sir. My question was, so we are calculating gauge pressure here by removing P naught. So then, how at the end can we just add P naught to make it atmospheric pressure?
When difference when you're finding, Krish, then there is no need to add or subtract because difference will remain the same.
Yeah, yes, sir.
So we generally do find difference, correct? Dear?
Yeah, yes, sir.
Questions are asked in particular to test your knowledge on gauge pressure. They will ask what is gauge pressure. So in
Yes,
that
sir.
case, what you do, you find pressure and subtract P naught from it.
Yes, sir. Thank you, sir.
Okay. Now, this was the convention. Now, the method that we are to innovate. And the method that we are to innovate is very simple. Forget about sphere for the time being. Forget about sphere for the time being. Instead of sphere, think of the water table. All of you please do concentrate on the water table. Think of
Yes, sir.
water table. Is it cylindrical with certain part of it which is in shape of hemisphere scooped? Think of the water table. I'm not asking you to look into the laminar figure. Think of a sphere and think of the water table above it. Is it okay? Are you getting it?
Yes,
Yes,
sir.
sir.
Look from top this structure, then you will be looking at this part of it, and that part will go, but is falling short of completing cylinder and falling short by hemisphere. Agreed? Take
Yeah,
it, take
yes,
it,
sir.
take it.
Yes,
Take
sir.
it.
Yeah.
Is it okay? This is
Yes,
the
sir.
one, and above it is what for you
Yes,
to be
sir.
seen. It's shaped to a cylinder with this part removed, right? What is this
Yes,
part to
Yes, sir.
you? Hemisphere, correct?
yes,
Yes,
sir.
sir.
Okay. So this is water table to us. This is water table. On water table, how many forces can act? One from top. What is that? P naught into area. Agreed?
Yes, sir.
Top, top. Getting it or not? P naught
Yes,
Yes,
into
Yes,
sir.
sir.
area. Into area from top, right?
Yes, sir.
Got it?
Yes.
And then what we have? What else we have? We have its weight. Weight acting in which direction? Downward direction, right?
Yeah.
Yes, sir.
Yes, sir.
It will be rho multiplied with volume. Now, what volume you are to associate with it? Pi r square. R is given to you. R square and h is also given to you. Correct?
Yes, sir.
Yes, sir.
I r square small h minus volume of hemisphere, right?
Yes,
So
sir.
2 by
Yes, sir.
Yes,
3,
sir.
2 by 3 pi r cube. Check it here. 2 by 3
Yeah,
pi r
yeah, yeah.
cube. Is
Yeah.
it or not?
Yes, sir.
Minus volume of sphere, right here. So what is volume of sphere? Hemisphere. 2 by 3 pi r cube. Agreed here, all of you?
Yes,
Yes,
sir.
Yes,
sir.
sir.
Okay. So this multiplied with rho will get you mass of it. And mass multiplied with G. This is water table, so rho is known to you. Is it okay?
Yes, sir.
Yes,
Yes.
sir.
So this is weight. And weight acting in which direction? Downward direction, right here?
Yes, sir.
Yes, sir.
Yes, sir.
Two forces shown in downward direction. What about upward direction? This water table is at rest, correct? Yeah.
Yeah. Yes, sir.
Yes.
So there must be a force in upward direction, and in upward direction, it is in contact, as you know, with hemisphere. That is the only component which can apply force in upward direction. Agree?
Yes, sir.
Yes,
So
sir.
force in upward direction will be this plus P naught A, right?
Yes, sir.
In one go. Clear, yeah? That is
Yes.
what you have to get when you integrate as well. But here we get by slight change, thinking out of box, slight change in our rote method of learning to, then you will flip it from what is here in question. Of course, is position on a sphere. That is without doubt to be seen. But we are flipping and looking it from other perspective. And the other perspective being, instead of what the question is positioned on, look for the other element. Because the other element is getting you an easy access to question's answer, correct?
Yes, sir.
Yes, sir.
Okay, but please try to let it get into your skin. And that is important for us because there are many a question coming your way on this principle. So let it sink. Is it okay?
Yes, sir.
Yes, sir.
Sure, Krish?
Yeah, yes, sir. Yes, sir.
Okay, good enough. Okay. Now, what I am to leave you with is a question which you will ponder back your places. And that being, write down. A cylinder of length L.
Sir, you're not visible. Your camera is off. Are you able to see, sir?
Sir?
No.
No, I'm not. I can't hear also.
Sir, you're not visible and audible.
Krish,
Yeah?
no, it's still not working, right?
Yeah, it's not
Uh,
working.
okay.